guys, welcome back to my YouTube channel. And today I'm up with the next question of the top 150 interview question series of Lead Code. So let's get started with today's question. Today's question is based on dynamic programming, and it is really important from the point of interviews, and also it's a good question to understand the basics of dynamic programming as well. So let's get started with today's question, and today's question is also an interesting question as well. So let's get started. So you are a professional robber planning to rob a house along a street. Each house has a certain amount of money stashed, and the only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses are broken on same night. We are given an integer array of nums representing the amount of money of each house. We have to return the maximum amount of money that you can loot tonight without alerting the police. So let's discuss the approach for the same. So I have written one of the test cases on my sketchpad, and the desired output for this is 4. So let's discuss the decision tree for this problem. So suppose I decide to rob house number 1. Let me just mark house numbers like H1, H2, H3, and H4. Okay, so it's good. I've decided to rob H1. So uh, so if I've decided to rob house number 1, so what all possible houses can we rob after robbing house number 1? So the answer to this is either house number 3 or either house number 4. Okay, so either we can rob house number 3 or either we can rob house number 4. Okay, so this is one of the decision tree that we have got after robbing house number 1. So this is one case. Okay, so suppose I decide not to rob house number 1, I decide to rob house number 2. Okay, so this is the second case that I decide to rob house number 2 instead of robbing house number 1. So what? So after robbing house number 2, what all houses can we rob? Can we rob house number 1? No, because house number 1 is adjacent to house number 2. Can we rob house number 3? No, we can't, because house number 3 is adjacent to house number 2. But we can rob house number 4. Yeah, that's the point. So let's draw a decision tree for this as well. Okay, so fair enough. So we've got a decision tree, and we can basically make a sum total. Like after traversing through this path, we get a total amount of 4 rupees, and after traversing through this path, we get a total amount of 2 rupees, and after using this decision tree as one of the cases, the maximum amount that can be looted is 3. Okay, fair enough. So I think we can use a recursive approach in order to solve this question, and it is simply easy to solve. But there, but the constraint is that the time complexity involved is the order of exponential, and the space complexity involved is order of n, uh, because we are using the auxiliary stack space as well. So this solution seems not to be a good one. So let's discuss the let's discuss an optimal version of this decision tree in order to solve this question. I know it's an easy question, but still I've discussed this approach because in an interview, in order to start an explanation, we need to discuss brute force solution as well. Otherwise, it doesn't give a good impression. Like it makes an impression in the mind of an interview that we have actually crammed the solution. So let's discuss the uh, optimal solution for it. I don't say it's optimal, like we are actually going to modify this solution a bit. So I think if we are using something like recursion, so let's just discuss one of the sub problems that we can actually find in this question, in this solution. So So, so suppose I have, as already told, if I decide to rob house number one, so what all options I have after robbing house number one? Assuming that I have more number of houses after house number four, like uh, I have five, I have six, I have seven, I have nine, or maybe I have again, what I can see, I can have eight as well. So, what all options do I have after robbing house number one? I think we have these many options from where we can actually rob, right? So, this is one of the sub problem that we can break it on to. And so, so one of the cases that either we can rob house number one, that is my nums of zero, and I will actually suppose I have passed this sub problem to a helper function because we are using the recursive, maybe recursive or maybe what I can say memoized approach. Like we have something like 2 to n, like second index to last index. We can actually we have these many options after robbing house number one. So suppose I decide not to rob house number one. So what all options do I have after these? So I suppose I assume that I start my journey from house number two. So what all options do I have after if I suppose decide not to rob house number one? So what all bracket of options do we have available in this? We have these many options. So it means we have um, we can just leave this as inner sum and we can actually move towards this. And what is the intention, like what we are actually finding out from this question is the maximum of max of 1 and 2. So this is what we have to this is what we expect our helper function to actually return. That's what the intuition of uh, this sub breaking of sub problem means. But 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 one more thing is that if we are moving forward and forward in our array, we are actually this sub problem also gets divided into its own sub problems, right? So ultimately we will get our answers after solving all of these sub problems, and the final answer will be returned by our helper function. That's what we are assuming. So rather than like what I can say, like rather than doing all of this mehnat, like all of this um, effort of just using our helper function to solve all this, why not use the technique of dynamic programming in order to solve this question? So what I thought of is like let's assume that I take two variables. Uh, I take take this solely rob 1 and rob 2. What has happened? Okay. So what I'm assuming from my rob 1 is that I am actually taking rob 1 as an option whenever I steal from house number 1. Okay. I'll add uh, um, the current result to it, like the current which I already have. And whenever I take from house number like just let me make it clear once again. Like I thought of taking two variables, like because I thought that rather than going with the help of this helper function and doing our task again and again, I thought of taking two variables, rob1 and rob2. With rob1, what I'm assuming is that I will actually steal from house number one. Like I will make a robbery in house number one. That's definite. So this is what it is. And from rob 2, what I'm assuming is I will never rob from house number 1. So the bracket of values that I have is from a nums of 1. That's what the intuition is. Okay. So now coming to house number 3. So coming to house number 3. So what I have actually assumed, like uh, let's let's just dry run this one by one. So what would be the value of my house number rob one at this time be? If I try to dry run on this very example is my rob 1's value would be 1 and my rob 2's value would be 2. So if I decide to rob from house number 3, so what would be a basic condition to rob from house number 3 is that we have already made a robbery from house number 1. So I have two options. Either I can go with this path or I only have this option of taking from my 2. So the maximum amongst these is 4. Okay, so now let's move further. So now let's make a decision to whether to rob house number 4 or not. So if I decide to rob from house number 4, so I have either I can, so my maximum answer stored over till here is house number 3. So, so as per our previous solution that we have robbed from house number 1 and house number 3 as well. So, so I have to so if I have to rob for house number 4, so I have to skip this house number 3 because it is just an adjacent element, and I have to make a decision from these two. So what is the maximum amongst these two is this one. So I have an option of 2 plus 1 equal to 3, and the existing maximum that we have, that is 4. So the maximum value that we can uh, rob, the maximum amount of money that we can rob from all the four houses is 4. Because if we try to loot from house number 4, the maximum that we get from house number 1 and 2 is the value of 3 by adding its own value as well. So this is what the basic intuition of this question is. Now let's discuss a pseudocode for the same. So now let's discuss the optimal code for this problem. So as I've already told that in the above explanation, I was not updating my rob1 and rob2 simultaneously. So I am assuming that my rob1 holds the value of nums of 0 and nums of 1 for rob2. Why I'm doing so? Because let me just mark one of the arrays. Like I have something like rob1, rob2, I have some I, and then an I plus 1, and I have all these values in a row. So I'm taking this rob1 as the first value, in which I'm assuming that I will start robbery from 0th house. And why I'm taking rob2 as nums of 1? Because in this value, what I'm assuming is that I will not start my robbery from the first house. So it means, as per the helper function algorithm that we have discussed, so rob1 will be will be finding the values for 2 to n, and rob2 remains for rob, and for the other half we'll be finding the values from 1 to n for the other option, that is rob2. That's what we are actually trying to imitate over here. So for rob1 and rob2, I think we all are clear that suppose I have only one house in a row. So if I have only one house in a row, so I have just returned, so my answer stands rob1. And if I have two houses in a row, I will return the max of rob1 and rob2. Okay, that's what the thing is. So now coming to if we have greater than two houses, so I'll iterate from second index till the last, and I will store my current maximum, the current maximum value that I have. I will store it in some current, and where I will assume that my maximum would be as per this logic. So it would be rob1 plus the ith index that we have, and we have rob2, because rob1 is being robbed previously before rob2, and rob2 is the one is the variable which will hold the last value of the house that is being robbed, last maximum value. It will hold the final answer. Okay, so this is what the intuition is. So the current maximum, like the currently the maximum value of my robbed value, which I have. will be stored in my current. So I think for the ith index we have got the answer. So in order to find the answer for I plus 1th index, I will simply shift this all of these to one places further. So what I will do, I will simply update my rob1 to rob2, because this is what the sub problem states, that we will just move one step further, and that's what we are actually moving. And I will update my rob2 to current. Okay, so this is what the intuition is. And I will, and after using these traversal technically, I can say that the final value, the final maxima, like what I can say in clear words, that my final answer will be stored in rob2, and I will simply return my rob2. This is what the intuition is. Okay, so let's discuss the time complexity for this code. So the time complexity is big O of n, and the space complexity is big O of 1, because we are only using two variables, rob1 and rob2. So variables don't occupy much of a space, and we are traversing through the whole array, so that uh, because we have to find the maximum amount of money that we can load in the neighborhood. So this is all about this question. So let's move towards the code for this problem. So I have rob1 as nums of 0, rob2 as maximum of nums1 and nums0 and nums1. That's what I'm assuming in this case, because I have to return the max from these. So that's why I've taken this. So this is one of the erroneous mistake that I've made. So just ignore it for a while. So after that, I'm moving from 2 to n, and I'm taking up my maximum as rob1 plus nums of I and rob2. So rob2 basically holds the max of these two values. That's what I've done over here. And as per the comment, let me mention that thing in one of the comments in my code as well, so that it gets pushed up into the GitHub. Like I assume that my rob1 is this and rob2 is this, and my I and I plus 1, all these values are going so on and so forth. So I'm simply moving all these values one step further, and my final answer will hold this rob2. Let's run this code, and now let's submit it. So it beats 100%. And let's analyze the time complexity, big O of n, space complexity as well, big O of 1. So I hope guys you have understood this question. If you have understood, please do hit the like and subscribe button, and share it among your friends. It would really help me to make more such videos, and also motivate me to be consistent, more of consistent. That's what all from my side. Thank you guys. Keep watching my channel.